Okay, so I've just got the weekly reminders up here. There's a lot of homework due on Wednesday tonight, just so we're all clear about that. As I mentioned, I'm flexible just in general about homework and extending things, but in this one in particular, I know there's a lot, so we can look to push some back. Um, but we'll explore some of those ideas. I mean, you can do all those problems, right? By now, we've covered all that material, but sometimes it's a lot to ask all at once. So anyway, just keep that in mind. Looking for a good effort from folks to do at least the first two, and then I'll say we maybe can extend the chain rule one. But the other two, have been up, for a week, obviously, but we've had that material for over a week. So I think the first two should definitely be completed. And then we've got our quiz. We've got our normal quiz on Friday, and it's going to be on this stuff, on these differentiation rules, very similar to the homework. So when you're doing that homework, do a nice job, take good notes, write your solutions down in detail. I may even pull one right from the homework, and you'll do well. Okay, are there homework questions? You guys want to look at some homework before we get started? Are there other things you're interested in looking at? What would you like to do?
Could we take a look at problems 2 or 5 on trig derivatives?
Yeah, sure. Okay, let me see what 5 looks like. Is this the one you're talking about? This one doesn't look too bad. Maybe we should just talk about this one if this one's confusing. And then you can look at both of them if you guys want. It's funny, every time I seem to do this, I think it crashes when I try to do this. It's about to crash. Yep. But I think it's still here. Okay. So the first part is simply just taking the derivative, and it's just a simple sine and cosine one. And we know sine changes into cosine, and we know that cosine changes into minus sine, right? So if we did f prime, this is just 7 cosine. You get the minus sign on the other one because cosine changes into minus sine. So that's the derivative. I've got my derivative sign there. It's kind of hidden. There we go. That would go right in there. Were you having issues with that part at all? I know yours maybe looks a little bit different, but is that part okay?
Yeah, that part's okay.
And then we just want to plug in this particular one, it wants us to plug in 4/3 pi. And if we think back to our trig, we can use a calculator on this if you guys want to, but 4 pi over 3 is one that we know how to do, right? 4 pi over 3 is down here. I'm not teaching pre-calc this semester, so real quick, that has the terminal point minus 1/2 minus root 3 over 2, I believe. And you use the x value for cosine and the y value for sine, right? So if we did 4 pi over 3 minus 6 sine, I don't know if the 4/3 pi was the tricky part, right? That's the same thing as 4 pi over 3. Then you would just use the x value for this one and the y value for this one. And just simplify that down, or just enter it right like that. It's probably a good idea. Try not to do decimals. I don't know if I've said that enough here. I try to mention that as much as possible. When you have a problem like this, or there's lots of problems, like especially in the derivatives, where you're plugging numbers into trig functions or exponentials or logs or whatever, and you're going to get some decimal. Don't plug that into your calculator and try to enter in decimal points, because you might have the right number of decimal points. One of the frustrating things about web work is it oftentimes requires some unknown amount. And so the best thing to do is just avoid that by just entering the number in as itself. So for example, if you had pi, for example, which is approximately 3.14, but we know that that just keeps going forever and ever, just enter the pi part instead of trying to type in decimals. Right? And pi, I think, is usually just pi in this. situation. Anyway, so just sort of mentioning that as a potential issue with this one. Does that clarify that one for you, Gregor? Anyone else?
Yeah, that's
So
good.
would
Thank
you
you.
plug in 7 cosine and then 4/3 pi in parentheses, or would you plug in like something to do with the -1/2 for the final answer?
So cosine at 4/3 pi is -1/2. And so if I take the answer over to the actual spot, it would be 7 times -1/2 minus 6 times minus √3/2. And you could simplify that a little bit, right? You could be like -7/2 plus 3√3. If you need some trig review, I'm happy to send you some stuff. And I would kind of expect people would. A number of people actually reached out before the course and were like, hey, I haven't taken pre-calc in a while and I'm worried that I don't have enough trig. And I sent them a bunch of stuff. They did some practice and that was good. If you're in that boat, if like doing 4/3 or cosine of 4/3 pi and how that becomes -1/2, if that's just complete, feels like it's new information or something, let me help you with that.
Can
Yeah.
we do the quotient one, number 8 on that one?
What other questions about this one? Finally figured out how to do this, by the way, so I can just save it right into the folder. Why is it doing that though? Save. Okay. I think maybe we should look at 2 before 8. Let me see what 8 says first. Oh, 8's not. You're talking about from a different one. So let's just quickly look at this. I want to look at this one. I guess I feel like I'm just going to end up doing all the homework, but that's okay. This one's a little bit tricky. We can look at this one. Okay, now this is going to crash, and then we'll open it up. So this is telling us that we're taking the derivative of something in the numerator, right? That's what this means. Take the derivative. That's what the d over dx part means, right? And then in the bottom, we're not taking the derivative. Right? So the bottom is just like staying the same. And what it says is it's going to simplify into a constant. And my guess is that everything's going to cancel out. Cancel, question mark? And it probably has to do with whatever the derivative of cosecant is, which I don't happen to know off the top of my head. So let's pull out those derivative rules, check out cosecant, and see what it tells us to do with cosecant. So here's cosecant. It tells us that cosecant, when you take the derivative, changes into minus cosecant cotangent, which I think is what's in the numerator, right? So let's keep that in mind. Let's flip back over and do that. So minus cosecant cotangent. So when we take that top derivative, we get 9 times minus cosecant cotangent, right? We just took the derivative. So what happens here, Gregor? Gregor asked this question. What happens here now?
So cosecant times cotangent cancels with the bottom denominator, leaving you with -9.
Right. Yeah, so the negative sign ends up with a 9, and we end up with -9 on that one.
I completely missed that. Thank you.
So I don't know if it was the notation thing, right? Maybe I'll just delete this real quick just so you can get a better look at it. But this part right here is telling you to take the derivative. And I've been using that notation, but I know that's, if it's not familiar, you might miss that.
I didn't cancel anything out. That's what I did wrong.
I see. Okay. That one okay? Other thoughts about that?
So when the d over dx is just on the top, it's saying just take the derivative from the numerator. But if it was like set out in front of the whole problem, it would be take the derivative of everything.
Yeah, that's a good point. So if it was like this, like out in front, and maybe sometimes they do parentheses like that just to be clear. It's like, I'm taking the derivative of this whole thing. I try to do that, at least in my notes. Then yes, then that would be a quotient rule. And you'd have to do that. But since it's just kind of stuck up in the numerator with that one thing, it's referring to the one part. Yeah.
All right, thank you.
Other thoughts? All right, so I've saved those couple in the homework files folder. Someone asked another question about a different problem. Is that right? Was that from product quotient rule?
Yeah, it was problem 8. It's a tangent. It's finding the equation of the tangent line, and I'm following the steps, and I'm just not getting it.
Yeah, so this is a couple people were talking about, I think this one in the Slack last night, if I remember correctly. I'm just gonna close it out and open it up. Just cut to the chase. All right, there we go. So we've seen these problems a lot, right? These equation of the tangent line thing. Just to be clear, you 1, take the derivative, 2, plug in the point that you're given, which in this case is 4. And then 3, write the equation of a line. And I know that's a big step itself or whatever, but it is the same process every time. And so the tricky thing about this one, or one of the tricky things, is that the derivative is a quotient rule. So let me just start it up here because it's going to be a little big. It's going to be a quotient rule. But it's a power rule within the quotient rule. So it's not too bad, right? So it's going to be, and let me use that same notation I just used a second ago. Take the derivative of the top piece. And if you're not familiar with the quotient rule, let's just flash that back up too. All right, we're going to use this quotient rule. This says when you have a quotient rule or a division thing, you do this. And so I'm about to write down the right-hand side of that, right? And so it's going to look like that. Again, you should have that out and reference it. Go back to things. So we're going to do that. So I'm doing the derivative of the top, leave the bottom alone. So that's this. So f prime g minus f times g prime, all divided by the bottom squared, right? So g squared. So that's the setup, and from here it's not too crazy. So I don't remember who asked that question, but set up okay so far?
Yeah, I just didn't do the quotient rule. I just went with the original 2x over 1x squared. So
okay, and you're not alone in that. You know, people were talking about that in the Slack last night. Someone sort of approached a different when it's a fraction. I mean, for one thing, it's in the product quotient rule section. So most things in here are either the product or the quotient rule. But we do generally want to be thinking like, which one of these things does it look like? And if it's not a super simple function, which at this point we're not going to be looking at super simple functions for the most part, it's probably going to be one of these three things. And so it's, you know, the more you look at these, the better you'll get, but it's usually pretty clear that it's one and not the other. I'll just mention while we're on the topic though, you can think about this one as a product rule, because I think, if I remember correctly, I think Simon was talking about this one and did this and was thinking it was maybe a product rule. If you rewrote this like this, right? So you bring the denominator up and make it to the power of -1, right? You do that -1 thing with the fraction. Does everyone see what kind of how that worked? Then that becomes a product rule. It's harder to do that way because it's a product rule with a chain rule. And so I wouldn't recommend doing that, but I'm just sort of saying we could rephrase things differently sometimes and we can end up with a different approach. So you could potentially phrase this one as a product rule. Sometimes people like really hate the chain rule or the quotient rule, for example, and they just try to make everything a product or a product rule, which is fine, but I wouldn't recommend it. Should we keep going with this one? Maybe I'll just like write down the next step, right? The next step would just be to take those derivatives, which are just power rules. And so the y prime is going to be 2 times 1 plus x squared. And then the power rule in the other one just becomes 2x. And you're welcome to simplify it, but you really don't need to, because you're just about to plug the number 4 in. And in my opinion, it would be easier just to plug the number 4 into a bunch of x's and then simplify numbers instead of like distributing, worrying about exponents and things like that. This one's not hard to distribute, I just note, but there's no real reason to, right? In other words, the next step, so this has all been step number 1. The next step would be to plug 4 in, and I would just plug it right into this. You can do whatever you want, but you know, this is the way I would think about doing it. Right, and this is going to be the slope. And then you have your m, and you write the equation of the line in part 3 there. I clarify something else about this one? Again, this one in particular, I had at least 2 or 3 people asking questions about, so it's not a problem like going over this one. You should feel like you're not alone in asking a question. Yep.
So at the quiz this Friday, we don't. It's this material, the equation of the tangent line, but we're not like doing the.
I probably won't ask you to do an equation of a tangent line. I'm probably going to just ask you to do some derivatives.
Okay.
Can you just explain how to write the equation line? I
So-
don't want you to like do the whole problem for us, but like that's the one part I just don't understand.
Okay, I'll do it again, and I don't mean to be rude by saying this, but I've done it like 4 or 5 times already, and what I would suggest is just going back and looking at some of those videos for more details. I'll write I'll kind of summarize again, but you know, the nice thing about having all these recordings is I feel like I shouldn't have to like do the same thing repeatedly. But let's just talk real quick. So you want it to be y equals mx plus b, and we know that's problem because that's what it's given, right? It says y equals blank. And so we know it's y equals mx plus b. We just found m. M is what you calculate in the first couple parts, right? So we want to find b. And so you plug in an x and a y, which were also given, to find b. So you take the x and the y that are in the problem, and you plug those in to find b. So it would be like 8 over 17 equals whatever the slope is when you simplify that thing, times the x value, plus b, right? And then solve for b. And I don't recall exactly in the notes where we did that. I can slide up and look, but if you just kind of figure out what part of the notes we did those. There's also a couple when we went over homework problems. So I did a couple of the homework problems where I did those in detail. And to be perfectly honest, I've said this before, my videos are not going to be as nice as like a Khan Academy video, for example, because someone's getting paid big bucks to write a nice video there. So if you really wanted like a quick explanation on how to do the equation of the line, if it was me, I would, instead of like searching through my past videos, just Google writing the equation of a line. Tons of videos will come up. They'll be 3 or 5 minutes long, and you'll get a nice, a nice detailed answer there. I don't mean to avoid that, but I'm just trying to help you like be a little more self-sufficient here.
Why is 8 over 17 and the y and the x spot when you wrote it down below?
Oh, sorry. Thank you. So it should be just in the y spot. Sorry. Yeah. So the 8 over 17 was the y. The x was a 4.
And then the m is the slope that we got from the prior step?
Correct. Does everyone see that? So this 4, I just should have put that 4 right in there instead of the, yeah. My guess is 8 over 17 has something to do with the slope. Maybe do we get like a 17 in the denominator maybe or something like that of the slope?
Yeah,
Anyway.
you get a 17 in the bottom.
Okay. Yeah. So then you'll have like, you don't have to worry about a common factor in there or a common denominator. Other thoughts? Happy to clarify some more stuff there. Other homework problems? How are we doing on time? Happy to look at another one if you guys want.
Yeah, can we do problem 1 of chain rule?
Yes. And then what we're going to do after that is look at a bunch of sort of chain rule problems. So it's good to look at a chain rule right now. Let me save this one in the folder real quick. Homework solutions. Okay. Which number? Oh, someone put something in the chat. Sorry. That's
1.
Problem 1. Can't remember to open this chat up sometimes. If I don't respond to the chat, just holler at me. Okay. So yeah, let me send this over to the thing first. So this first problem is just getting you to think about the chain rule before actually doing a chain rule problem. So it's sort of, it's just getting your mind in the right spot for it. And I think before we actually look at this one, what I'd like to do is just go back to the notes real quick and notice how it looks just like the notes. Right. So on all these chain rule examples, we just did a whole page last time and it went onto this page. Each and every time, what we did is we started by looking at the original thing and then pulling it apart into the composite parts. Right. So in other words, we're trying to think about this as two things being plugged into each other. And then we're thinking about, well, what's plugged into what? And that's where the F and the G come in, right? So in this particular problem, we noticed how there's an E raised to a power. And so that led me to e to the x being the outside function. And then what was inside the e to the x was a 2x squared. And notice how we have individual rules for each one of those things. That's the thing that maybe I haven't said yet. When you pull them apart and you're looking for the individual components, we need to take the derivatives of those individual components. And so we need to know the derivatives of the individual components. In other words, e to the x is good because we know that derivative. 2x squared is good because we know that derivative. And so we're going to combine that idea. But notice how we pulled them apart. That's sort of what I wanted to point out here, because that's how this problem begins. It begins by getting you to try to pull this apart. Right? So it's saying, here's some function where two things have already been plugged into each other. What are the two things that have been plugged in? Again, the exact same thing we did in the last class starting. And we're not taking the derivative here. That's like the entire problem right here. It's just pulling them apart and then moving on. We're going to use that some other time. So let me just pause there and see if that makes it clear. I don't know if the question structure was one of the things that was confusing you. Is that all right? So this is a composition problem. So that's the answer to the first part, right? Hopefully that was clear. We're doing f of g of x. This is a composition. That's the definition of that. And what's being plugged into what? What do you think about that, Rashid? I think that was Rashid who asked that.
Yeah. So I think g of x will be tangent of x, but I don't know f of x.
I agree. Tangent is inside something. So what's it inside?
The square root.
It's inside a square root. Yeah, that's it. Right, like with this thing in mind, if I did f of g of x, that would be taking out the x in f and then putting in the g, right? And so that's all this problem wants us to do. It's just sort of getting our mind around in the right place for these chain rule things by evaluating the composition part. Questions about that one? So let me just sort of page ahead and just look at a couple. I'm wondering how many there are like that. So then on the next ones, you're actually going to do the chain rule. Right, so the first one is really just getting you to sort of think about pulling them apart, just like we did in class, and then you're starting to actually do the things. We did this one in class last time, I think. Other homework questions, I guess? Maybe let's stay here for a quick second. I would like to start. we should probably get started. I'm happy to maybe do a quick thing if someone's got a clarificational kind of thing. Anything else? All right. So if you remember where we were in these notes, we were doing the chain rule. I can't undo here, huh? And before we actually go, and what I'm going to do in a second is we're going to do a breakout thing. I'm going to ask you to think about the ones on the next page, right? There's a whole bunch on this next page that are just combinations of previous rules. Everything on this page is not a simple rule. It's a product rule with a chain rule, or a natural log rule with a quotient rule, et cetera, et cetera. So they're all combinations of rules. And in order to help us think about these, the chain rule, I just want to kind of remind ourselves what we did on this one particular problem, the one on the left, because maybe this will help us think about shortcuts. Right, so I already kind of just explained how we took this original function and we broke it up into the two pieces, right? What's inside what. But notice the way that the problem actually worked and the way we progressed to this answer. What we did is we ignored what was inside the e to the x, which was the 2x squared. We just ignored it, took the derivative of just the e to the x part, and then put the inside piece back in, right? And that ended up being one of the components of the final answer. And so I know the f part is usually the confusing part because you're taking things out, you're taking derivatives, you're putting them back in, all that kind of stuff. It's like, and it's confusing notation. But what I'm trying to point out is you just ignore the hard part of it, take the derivative, and then put the hard part back in. That's sort of the way to think about it. And then since you kind of ignored the inside part, you account for the inside part by just taking the derivative of that and then multiplying by that. All right, so when you think about it like that, I think that's sort of the shortcut, quick way that people get to answers in chain rules without writing all this stuff down. And so I just want to kind of do this problem one more time with that sort of alternate, I don't know, approach. It's the same approach, it's just kind of shorthand. So if we had e to the 2x squared and we wanted to do the derivative, you ignore what's inside the function, right? So I'm just going to do like, okay, I'm just going to ignore what's in there and just forget what's inside there. And then when I take that derivative, that just stays the same. Okay, and that's how I'm thinking about in my mind what the outside derivative is. And then I just write that down as part of my answer. And then I remember, oh yeah, there was a thing in there. What was in there? It was the 2x squared, right? I totally ignored that for right now. And so I just put it back in. So that's part of the answer. And then since I ignored it, I've got to account for it by taking the derivative and multiplying on the outside. Right? So you can skip all this kind of intermediate note stuff and pulling stuff apart. Just sort of thinking about it in that respect. And that's eventually, I mean, you don't have to get to that point, but that's the goal, is sort of get to the point where you don't have to think too hard about these chain rule ones. You don't have to write down all this stuff. You can kind of think through it and not jump to the answer, but get to the answer with less writing, I guess is how I would describe it. Are there thoughts about that before we just jump into some more practice problems? All right, so then, like I said, I'd like to do like just a few breakout rooms and just let you think about these and potentially think about them together. And maybe we can just sort of start by making note of what we're going to do on each one. Does anyone have an idea of like what rules are going to be involved in this first one? We've got two things being multiplied. Yeah, go ahead, John.
So it's a product rule, but inside of the product rule is a chain rule.
Good. So it's going to be a product rule because we've got things being multiplied. and it's going to have a chain rule inside because we have the e to the 4x squared. And so that's the kind of just recognizing that right off the bat is sort of like, all right, I sort of know where we're heading, and then you start to dissect it and be a little more careful about it. That's perfect though, yes. The second one then, so we've got natural log, so it's an ln rule, right? But then what's going to happen when we take the derivative of the inside part?
Quotient.
It's going to be a quotient rule, good. Right, because you've got the derivative or the inside part, the 2t over square root is a quotient rule. Or you could also rewrite that as potentially, you could make it simpler to make it into a power rule. I'll just sort of mention that. I'm gonna do it as a quotient rule just to make it harder. No, make it just give you something else to look at. But you could transform this inside part into a power rule. Maybe think about that. What about this one? We've got square root. This is kind of similar to the one that Rashid was asking about with the square root of ln, or what was in there? Square root of tangent, was it? But now we've got a square root with a product inside of it, right? So what are we doing on this one? What's the first rule?
So it's a product rule inside of the chain rule.
Yes, good. So it's a chain rule first, I would say, with a product inside. And when I say like chain rule with the product inside, just kind of jumping to the derivatives, right? If we have a chain rule, like the thing on the right here, this is the part that's going to end up being the product rule, right? Because you take the derivative of the inside, and the inside is going to end up being a product. That's sort of what we're talking about here. And this is the same thing on the next one too, right? It's also a chain rule with the product, but it's just a different type of chain rule. I think I can do that. How do you paste it though? You can copy it, and then what? It's not paste.
Hold it. Is that the iPad? Hold the cursor down.
Nice. Thank you. What else? What other options you get in there? Signature, stamp, sticker. Give me a sticker. Oh yeah. Chain rule as graduated. What else is in there? Nope. Paste. Okay. Anyway, so we've got, there's a lot of time left in the class, 45 minutes. I was going to, like I mentioned, there's a lot of people here. This is great. Maybe do like groups of 3 or so and think about this. I don't know if you've done this before, but one thing you can do when you share screen is you can share a whiteboard. Let me just I've done that, I think, once maybe before I started doing it this other way. And let me just show you that. So if you click share screen and a bunch of stuff comes up, one of the options is whiteboard. So you can share like screen 1, screen 2, iPhone, specific windows. One of the options is whiteboard. And when you do that, it does this kind of thing. I'm not sure exactly what you see, but it gives you this thing that you can write on. And if you have a tablet, maybe this is really great because you can just write on it like I'm doing on my iPad. Like I know Mariana has one, for example. Or what I'm doing right now is actually just using my mouse. So it's not awesome doing a mouse, but you can at least sort of think about, oh, well, if you had this thing, maybe you could just do like, this is the F. Or maybe I guess that's the G. Maybe you're better at this than I am too. Anyway, it gives you a way to at least interact with each other rather than just talking. I know it's really hard to say, just to describe what you're doing mathematically. That can be challenging. So I'd like to spend just a little bit of time on this, maybe 20 minutes, maybe less, 15, 20 minutes. Just at least let you think about this stuff. This is the kind of stuff that I'm going to put on tests. And I like questions like this on tests because it evaluates multiple rules at the same time. And so I'm not, try here. And I think about half of you, if I was looking at the homework, about half people have started the homework and done most of it. And about the half people have not done any of those massive amounts of homework we have this week. And in my opinion, people have not done the homework yet. This is the most important to you because you have got a mountain of homework ahead of you tonight. And this is your chance to figure out how to do that homework. So engage in it right now. 20 minutes, 15, 20 minutes. We can spend the last 15, 20 minutes looking at those answers. And if you understand the stuff on this page, you're very well prepared for the homework, the quiz, and you're going to do well. If you're still struggling with this stuff, it just should give you some indication that you need some more help, which is fine. Anyway, I'm done rambling. I'm going to do some breakout rooms. So let's see. Gonna do. Six of them, and I'm going to open them up. Keep in mind, you can also, I'm going to kind of pop through them and see what's going on, but you can also raise your hand. You can call me in, etc., etc. But I'm going to kind of run through them as well. Please try to be active in this. Just, don't, I know I hate when teachers do this stuff, make people be active, but this is really the time to figure this stuff out. So anyway, I'm opening up the rooms. Go ahead and move over there. I'm going to run through them myself. We'll come back shortly. How's it going, guys? I clarify anything? You doing okay so far?
Yeah, so we figured out the first half of the chain rule, and now we're plugging that in using the product rule. But I have a question. So like 8 of 9, So we're working on the first one. So 8 raised to the 9 would be 9x raised to the 8. And then, so the product we got from the chain rule, e raised to the 4x squared, just like the example you did before, half of it stays the same. And then we have 8x. So we have three parts, right? So I'm just confused how to use the product rule with that.
So I think it's sometimes helpful to write at least loose notation like I used. So let's see here. Yeah, 1 sec. I'm gonna send my iPad in here real quick so that I can write on it. Okay, so if you have like x to the 9 e to the x squared, and you want to do the derivative, should have just, we're doing the derivative, d over dx, then I think it sometimes helps just to like do like at least note what you're gonna do. You're gonna like take the derivative of the first piece, leave the second alone. It doesn't have to be this detailed necessarily, but I'm gonna write the detail just to be clear. And so when you said there's 3 pieces, I think I know what you mean, but it's 2 terms technically, right? It's the thing separated by the plus signs. And yeah, you use the chain rule here, but that's just going to be a bunch of stuff multiplied. And so it's still just 2 terms. One of them has three pieces or something, right? So it'd be like 9x to the 8th, e to the x squared. And then you just said what the derivative of the other one would be. Oh, I didn't write it down right though, right? Wasn't it 4x squared? What was it?
E raised to the 4x squared times 8x.
Right. I just forgot to write the 4 in there. So we would have, like you said, 8x times e to the 4x squared. And so this is still all one term because it's all being multiplied, but it has 3 parts, you're right. And I think that's what you're referring to. But do you see how the product rule sort of worked in there? And knowing the product rule and the chain rule are there are one thing, but I think this first part of just writing it out sometimes is helpful. Sometimes people will even, instead of writing the d over dx, you just write like a prime sign like that. That's even shorter hand notation. Just, it's for your own, it's for yourself to know like, what am I doing? Oh, I'm going to do this. And then you just take that and you do those individual components. And then if you mess it up, like this is a web work problem, for example, if you mess it up, you have something very detailed to go back and say, well, where did I go wrong? If you're just kind of doing all this stuff in your head, it makes it very hard to correct something, right? Anyway, does that, you see what I did there?
Yeah. So that's the final answer, right?
That would be the final. You know, it could be simplified. Like you could take 8x to the 9th and make that 8x to the 10th, for example. But on a test, I would like just the blue. The blue's fine. Thoughts about that one?
No, looks good. That clarified, so I'm good.
Okay. I'm gonna run over to another room, but raise your hand or send me a message if you want me to pop back over here.
All right.
Oops.
Hey, just checking up. How's it going?
Well,
Oh,
trying to
looks
do
good
that
so
again.
far. Sort of. So the G prime, were you just talking about that part?
Yeah, I erased all that to like make room though. Hold on, I'll try to.
So which rule are you using first?
Product rule.
I see. Yeah. Okay. And so is the idea what you're doing here is this part what's going on down here? Is that what's happening?
Yeah.
Okay, great. Yep. Yeah, it looks good. So what is this bottom part, would you say?
So for g of x, to find the derivative of g of x, I thought I had to do the chain rule. So I like found all the different like parts of it, and then I wrote out chain rule down here with all the like f of x and g of x, and then I just rewrote it up at the top again.
Okay, so this is not quite right, but you have everything that you need, right? So you want to then do f prime with g in it, and so you really want this is one part of it. And then yes, this is totally great right there. And so then the
Oh, I
total
messed up.
thing is going to be just this. Right, this is the derivative of the e to the 4x squared part.
I did product rule instead of chain rule.
Yeah, I thought that's maybe
Jesus.
what was going on there. Yeah. And so this would go right here then in that case. So what I was just telling the last group, and I don't know if this is going to be helpful, someone is asking me a question, so I'm going to shoot over to another room quick, but you're doing this correctly, but it might be helpful to kind of do what I originally do, which is if you want to do the product rule, you kind of write out what you're going to do, because it seems like maybe you're losing track of that a little bit along the way, which is common because it's an involved problem. Right, so you map out the product rule. You say like, all right, I'm gonna take these derivatives and I'm gonna multiply them in this kind of way. And then you think about what each one of those things is separately, right? And then this part would be kind of down here. Right, this one is just a power rule. And so I know that's a little bit tedious to write out, but you can see that when you just kind of write a bunch of stuff on the left-hand side of the page, eventually then trying to put it all together sometimes is a problem. But if you have this, the part I have in red, it gives you a roadmap, right? And then you're just putting the pieces where they need to go. Does that make sense?
Kind of.
So, yeah, go ahead. This is, and again, so this part is not correct on the bottom.
Yeah. I'm not sure how I'd like rewrite the problem after. I thought I had to like have all the parts for product rule on the top to be able to like put that together before I could rewrite it.
So you've got it all, right? So this piece, for example, is going right in here. That's good. You don't have to do anything to that second piece. And then the bottom piece just needs to be finished. I accidentally cleared it off, but like this ends up being e to the 4x squared.
Oh, okay.
And so the final derivative is this. All right, this is g prime. This is f prime with g plugged in.
I'll try that.
All right, I'm gonna run over to this other room. I don't know what's gonna happen with this. It may clear out when I leave. I'll be back. Hey,
That's
sorry, I was trying to help someone else there.
Oh no, yeah, we're just having some trouble with the second one.
I think that if this is what we're going by with the chain rule, this is what it should look like. But this right here doesn't make sense. Like, why would the shit that we're doing for my bad, why would the ln, which is what we're getting for this, why would it be multiplied by itself when we're multiplying by g? Feel me? Like, to get the chain rule, it's f prime. So this is what we got for f prime, but it's multiplied by g, just base g. So we
Yeah.
multiply it again by the 2t over the square root t. So wouldn't that just cancel itself out and that would just leave us a 1, right? Or are we multiplying it by itself? And then it's the big quotient rule. And the quotient rule is fine. At least I think it's good. Like we all thought that the math was calm.
Yeah.
But this is what don't make sense to me.
So
Like,
so what's written on the page looks, a lot of it looks good. So we do want to do the chain rule, like this is what we want to do. And this part, the f prime of g of x is this thing.
We're
Because of exactly what's written here, right? The inside or the outside part is natural log. When you take the derivative of that, you get 1 over t. But then you need to plug g back in. And that's what this is down there. It's the 1 over, and then what's on the bottom should be g. And so the f prime of g of x part is that thing that I've got boxed in there. I think that's the part you were talking about, Sebastian. And it looked like you multiplied by g. Is that right?
yeah.
So when we write down this,
And I thought that whole thing was this.
yeah,
Was the thing that you had boxed in, and then we had to multiply that again by just the
oh
regular g.
okay.
That's what
So,
wasn't making sense to me because I was like, there's no point to do that.
yeah.
so this,
But I didn't know that we had to plug that into the bottom part. My bad.
yeah, I think that's what you're missing is this thing I've written on the bottom, which is now in green. That is g plugged into, not multiplied by, plugged into the derivative. And so we calculate the derivative without the g in there. That's where the 1 over t came from. And then we put the g back in, which is why it's now not 1 over t, it's 1 over that fraction thing. And then yes, the inside part, the g prime part, is absolutely then a quotient rule. I haven't checked the quotient rule part work yet, but that's the right idea. Like this is definitely the right form.
Do you multiply it?
You multiply, yeah. So the multiplication is
The quotient.
The chain rule.
this right here. This thing I've got in yellow now.
Okay.
That's this one.
Yeah. Okay, that makes sense.
So that whole all that stuff at the end, do we have to simplify that, or is that
Let me
Just
see if
kind
that
of-
looks okay. So you do f prime, and this should be multiplication here as well. So it's like this times this.
Yeah, I got mine like that.
So f prime g, where's g? So g is just square root. So the negative sign shouldn't be there, right? Where'd that negative come from? Minus f g prime. So we're close here. Also running out of room. I'm going to try to do it on the right side of the page. So if you have square root of t, that's t to the 1/2, right? So when you take the derivative, you get 1/2 t to the minus 1/2 because you do 1/2 minus 1. So you almost have that, but it should be this part. And as far as simplifying, I would just not simplify it. I know this is getting really messy because I'm trying to run on top of everything, but yeah, go ahead. Were you saying something, Michael?
Oh no, I was just reading. Okay.
You should be on the outside. Huh?
Yeah. Thanks, Professor.
I think I'm going to come back together in just a minute here. Maybe we'll spend some more time in this on Friday too. Maybe I'll just go over like the first couple and we can think about it a little more on Friday. Okay, I'm going to bounce out of here and see if someone else needs some help. We'll come back together in probably 5 minutes.
Thank you.
How's it going, guys? Just checking in with everyone.
Hey, we're kind of wondering how the second one is a quotient rule, because it seems like you can just use the logarithmic function rule on that one.
Yeah.
So it's a logarithm. There's a logarithmic function one, but then when you take the derivative of the inside, that's going to be a quotient rule.
Oh, so you split the top and the bottom up to make the quotient rule for the.
Let me send my iPad in here. Am I in here? Yes, here we go. So it's ln of, what is it, 2t over square root t? Is that right?
Yeah.
So the ln rule says when you take the derivative of something that looks like that, you do, oops, not ln, you do 1 over that thing times g prime, right? Is that what it says?
Oh, really?
The ln rule? Or the logarithmic?
The ln rule is just ln of x goes to 1x. 1 over x.
I'm getting things confused. Sorry. I'm teaching calc in a couple different ways, and I wrote this a little bit differently in the other way I'm teaching it. I apologize. So it's a chain rule. With the outside function being ln and the inside function being this. Is this how you're thinking about it?
Yeah.
This is the quotient rule, though. So when you do g prime, you're going to do the quotient rule.
Okay.
Oh, okay.
Okay, yeah, that makes a lot more sense.
We're going to come back together in just a second here, and we'll go over a couple, and we'll probably spend a bunch of time on these same ones. I'll probably only do 2 today, and then we'll spend the rest of the time next time. But while I just have your attention, actually, I'll just do this to everyone. I'm not going to spoil it for you. I'm going to close rooms in just a minute here. All right, we're going to go over some in just a second here. Let me see here. There's a couple people who are still coming back from the breakout rooms. Yeah. Okay, great. So I popped around to most rooms and was talking to folks. I was really happy to see people talking about this. So thank you for doing that. It also helped me realize that we can spend some more time on this on Friday. No problem. Again, I would like to, I'm going to leave the homework the way it is for tonight, and I would like people to work on it the best you can, but I'll definitely extend the chain rule one. And my goal, maybe just in the last 15 minutes here, will be just to go over the first 2. And then, again, I'll give you maybe just a little bit of time to think about it on class on Friday, and we can look at the other couple on Friday as well. Do people have sort of general questions that they want to talk about before we just go over the answers for the first couple? And I'm just going to erase this so we have a little more room. Okay, so this is a product rule, like I mentioned. You should notice it as a product rule because you have 2 things being multiplied, right? So when we do the product rule, and you know, everyone, when I was popping around rooms, it seemed like everyone recognized it as a product rule, partially because we had said it was going to be a product rule before we went into the rooms. But what I was noticing was people are not doing the notation and writing things out sort of the way I have been in class, which I'm not going to force you to do necessarily. But I think what you're finding is when you don't write out the details, it's easy to get lost in a complicated problem like this. And so I would really encourage you to write out the kind of things I'm about to write out. So like, we're going to do the product rule, right? So what does the product rule says? It says, take the derivative of the first piece, multiply it by the second piece. add to that, leaving the first piece alone, take the derivative of the second piece. And I've done, I write it out like this every single time, partially so that it makes sense when you look at it later, but also partially so that we have a roadmap to see what we're going to do as we move forward. Because as we keep going here, we need to, it just gets complicated, right? So we've got f prime g, we've got our fg prime. I'm going to do a simple power rule on this one, but the e to the x one's a chain rule. And so then we've got a chain rule inside this. We're going to need some more notation for that, and then we'll put it all together. Right. So, but noting, doing this, and it doesn't have to be this detailed, but having a roadmap of what you're about to do prevents you from making mistakes, which is particularly important in math when things, one mistake is the difference between getting a web work question right or banging your head against the wall for an hour on a web work question. Just being careful, right? So anyway, let's do the chain rule part. So if we're looking at the chain rule on that one, that's a chain rule with the outside function being e to the x and the inside function being 4x squared, right? And so you want the derivative of f with g plugged in. Let me move this over a little bit. Right, so remember the way you think about that, the way I'm kind of trying to get us to think about this is you just do the derivative of f. So e to the x just stays the same. And then what are you doing with it? You're putting the g back in. So we have the 4x squared goes back in. Right. See if I can change those inside pieces. So that's the one component. And then since you kind of ignored the g part, that's where you'd take the derivative of g with the power rule to get 8x to the 1. And so this is that chain rule part, right? This is going to be, just to kind of summarize it, when we think about taking the derivative of e to the 4x squared, we get 8x, or let me write it the other way. We get f prime of g of x times g prime. Right, so that's going to be the component inside the chain rule. Is that all right?
Why are the exponents the inside?
The 4x squared, you mean?
Yeah.
So as I was kind of just honing in on this one particular problem, I'm trying to think about the rules we have and what I know about those rules, right? So when I'm looking, just kind of thinking about all these rules, I know that we have this one. I know how to take the derivative of e to the x. It just stays the same. And so I'm recognizing it as having something to do with that, right? And so I'm using that just by thinking about this as being e to the x with something plugged into it, right? So I'm trying to break down e to the 4x squared because we don't have a rule that says, what do you do when you have e raised to the power of a polynomial? And so I'm trying to break it down into two separate rules that we have. And I'm recognizing it as the e rule, which we know, and the power rule, which we know. And I can see, so maybe that's not the question. Is the question that how do we know that the 4x squared is inside the e to the x? Is that maybe the question? Or,
Well, basically, why is it the g, basically?
I mean, I guess can I clarify? Were you thinking maybe it was the other way around? Maybe g was e to the x and f was 4x squared?
Yeah.
Okay, so let's think about that. If we had f being e to the x and g being 4x squared, and we did f of g, right? That would be taking, I just wrote the same thing down. Sorry, I meant to switch those. F was 4x squared and g was e to the x. Then that would be taking the x out of f and putting in the g. Do you see that? Let me color code it real quick here.
I guess.
What if we made no, not move, let's make it blue or whatever. Right, so when I'm looking at the outside function, in this case, f, if I was going to plug something into that, you remove the x part. And so this over here, without the e, right, this is the function f without the x in it. And then if I was going to put something into that x, like e to the x, it would look like this. Right, just taking this piece and putting it inside there. And I mean, what I'm trying to do here is contrast what it would look like to have these two switched. And I think understanding how they look differently is, if you can see that, that's what we're getting. That's what we're going for. I'm going to write down the final answer here. We've got all our components. I'm going to erase this stuff. And so our final answer then, let's do it in blue. F prime of x using the product rule is what we just wrote down on the right, just kind of all with the things in there, right? So the power rule on x to the 9th is 9x to the 8th. E to the 4x squared. And then we're going to do plus x to the 9th, and then the derivative we just found. Right, this thing is going right in here. Times e to the 4x squared times 8x. That's the final answer. You can simplify it more. There's things you can do to simplify that I'm not concerned about the simplification. If you really wanted to, you can. What can I clarify about that? We're just going to look at the second one in a second, and then we'll move on to the other two on Friday. Anything? All right, let's check out that natural log one. So it's another chain rule, or I guess it's a chain rule. The first one was a product rule. We're going to do the chain rule because we have this fraction inside of a natural log. And so our outside function is the natural log, and what's inside of it is the 2t over square root of t. And I'll just remind you that square root is the same thing as t to the 1/2. And we're going to want to think about it as t to the 1/2 because when we take the derivative, it's an easy power rule, right? And so this one's just, it's really just a chain rule, but then we're going to have a quotient rule inside it. So it's a little bit different than the last one, right? The last one was a product rule that had a chain rule in it. This one is a chain rule that has a quotient rule. So let's keep going. So we take the derivative of f. I know that the derivative of natural logs are just 1 over t. But I don't want f. I don't want just f of t, in other words. I want f prime with g plugged in. So let me do it this way again. Here I am taking out the t. Right, what I've written down on the rightmost part of this page that I'm going to circle real quick in an ugly kind of way is the derivative of f without the t in it, right? So it's just 1 over blank space. The chain rule tells us that to do the chain rule, we want the derivative of the outside piece with the inside part plugged in. And so I'm just trying to write that down, right? And so you can see I've got that here. I just need to put something into the spot what the blanks are. And what goes in there is the function g, right? So I want g of t in there. G of t is this square root fraction thing. So it's 2t over square root of t. How does that simplify? If you have 1 over a fraction, what do you do there? Talked about that a couple times. You just flip it up. Yeah, right. Yeah, exactly. You flip it. You multiply, flip by the reciprocal. Multiply by the reciprocal. And so this is one of the pieces that we're going to use, right? This is the f prime of g. Now, g prime is where the quotient rule comes in. So when we do g prime on the bottom, we're going to do the quotient rule because it's a quotient. And it's a bunch of power rules. And so we just did we do the quotient rule? Or I guess I was doing it in someone's room. Anyway, it's a bunch of power rules, right? So the quotient rule would be f prime g minus f g prime. Take down the power, subtract 1 off the power. All over g squared. Right, so the quotient rule is a bunch of power rules, and then that can simplify down to something nice. Again, I'm not necessarily needing it, but in this case, it actually turns into something that's not too bad. So this becomes, in the interest of time, since we're almost out of time, this becomes t to the 1/2 over t to the 1. You subtract those powers, we'd have t to the minus 1/2. It's got this fly flying around here, driving me crazy. And so that's the other piece of it. And so we can write down our final answer, right down the bottom here. P prime of t is f prime with g plugged in times g prime. And that can also be simplified. We can talk about simplifying it if you guys are interested. I guess I'll just write down the final answer. If you want to simplify it, it turns into 1 over 2t. Because you kind of have like the square roots cancel. But I'm fine with what I boxed in. Again, the point of these is, do you understand the derivative rules? Can you kind of put together complicated ones? I'm less concerned about algebra skills. So that's the end of the period. Oh, I see something in the chat. Do you have to simplify f prime of g at the beginning? You can. Yeah, so that this original thing can also be simplified, Gregor's pointing out. You're welcome to. I'm not super concerned, right? So that could simplify. You've got t to the 1/2 over t to the 1. And so that could be 1/2 t to the minus 1/2 if you wanted to.
1 over 2t over the square root of t. I made the mistake of leaving the 1 over it. So do you have to simplify it so that it's the square root of t over 2t?
Oh, you mean you kept it like this?
Yeah.
You do want to simplify that because that's a compound fraction, and we don't want to have compound fractions. Yeah. Other thoughts? All right, we're going to spend more time on this on Friday. All right, there's 2 more on this page that combine everything. Do your best with the homework for this evening. Come with some questions on Friday. The quiz are not going to be, I'm not going to do super intense ones like this. The quiz is going to be more like the previous pages, like just 1 rule, or maybe probably just 1 rule. Yeah. All right, I'll stick around if there are other questions, but that's all I've got for today. Thanks, guys.